Sa situation number 7 of CE Volume 5, the beam BC shown is supported by a quarter circular arc AC having a radius of 4 meters. The frame is pin supported at A, B, and C. The pins at A and B are in single shear, while the pin at C is in double shear. Allowable shear stress of the pin is 112 megapascals, and the uniform load W is 3 kilonewtons per meter. In problem 22, determine the minimum diameter in mm of the pin at B, and problem 23, determine the minimum diameter in mm of the pin at C, and 24, determine the resultant reaction in kilonewton at A. Now, to attack these kinds of problems, since every joint is pin connected, pwede natin i-cut every joint, and analyze every member, then apply equilibrium equations kasi zero moment ang joint. First, draw a free body diagram 1, or member B and C, to simply analyze the joint B and C, and let X is my horizontal, and Y is my vertical component. By summation of force Y equals 0, since the load is symmetry throughout the span, then the vertical reaction of BY and CY are equal, then the resultant of 3 kN per meter uniform load times 4 divide nyo lang ng 2, and we get 6 kilonewtons, since the arc is quarter circle kaya 4 meter din ang length ng member BC. For our free body diagram 2, considering the whole structure. Summation of moment at A, equal to 0, assuming counterclockwise positive. Then, Bx times 4, minus 3 times 4, times 2, which is the moment arm, equal to 0, then we get the value of Bx equal to 6 kilonewton. For summation of force along x equal to 0, we get Bx equal to Ax, so Ax equal to 6 kilonewton, and for summation of force along y equal to 0, we get By equal to Ay, so yung Ay is equal to 6 kilonewton then. We see the vertical and horizontal reaction of A, B, and C are equal, so ang resultant reaction ng AB and C are equal din, so for solving the resultant reaction at A, equal the square root of AY square plus AX square. By substitution, we get RA equal to the square root of 6 squared plus 6 squared. By calculator we get equal to 8.485 kilonewtons. Now, for solving the problem number 22, what is the diameter of pin B, which is the single shear, if the allowable shear stress of pin is 112 megapascals? The formula of shear stress is equal to the force over the shear area, so the allowable shear stress equal to reaction at B over the shear area of pin B. To solve the minimum diameter, since RA equal RB equal RC, which is 8.485. Now, substitute lang natin ang mga given. Alam naman natin ang megapascal ay Newton per millimeter squared, so convert lang natin ang kilonewton na 8.485 into Newton, to satisfy our equation. So, 112 Newton over mm squared equal 8485 Newton over pi over 4 times the minimum diameter squared, so cancel lang natin ang Newton, so ang naiwan na unit ay mm, then calculate, we get D equal 9.82. Answer. Now, for the problem number 23, the diameter of pin C, which is the double shear, and if the allowable shear stress of pin is 112 megapascals, so shear stress equal resultant reaction at C over twice the shear area of C. Bakit twice yung shear area? Ganito kasi yan. Dalawa kasi ang shear area ng pin C, parang ganito. Diyan kasi mag-fail ang shear area against shear force, parang kung tutuosin, dalawa ang resisting area against the applied force, or the resultant force. So, substitute lang natin, 112 equal 8485 over 2 times pi over 4d squared, calculate, and we get d minimum equal 6.9 millimeters. So use 8 mm diameter. Bakit 8 mm diameter ang pinili natin for the minimum diameter? Ganito kasi yan. Kung titingnan natin ang choices walang 6.9, so ang malapit sa choices ay 6 and 8, But we cannot choose the 6mm diameter because magpe-fail na siya. Kasi ang minimum natin is 6.9, dapat di na tayo baba dyan. So kaya 8mm ang pinili natin. Now, for the problem 24, which is the resultant reaction at A, so may sagot na tayo dyan which is 8.485 kilonewtons.